All right, so we are going to continue working on part of the weather unit, which is also climate. So weather and climate go hand in hand. When we watched the video with Neil deGrasse Tyson, right, the part that he was talking about with climate was he was walking in a straight line and the dog kept going back and forth and back and forth in almost like an unpredictable manner, right? The dog represented weather, where he represented climate, where climate is going to take a long time to change, but weather changes from day to day, okay? So let's talk about what climate actually is, right? It's the overall view of a specific region's weather over a long period of time. This isn't just a couple of days. This is over years of time. Okay, this is the biggest difference between weather and climate, is that weather is on a day-to-day basis, where climate, they take a chunk of time and they look at how climate has changed. When we talk about climate change, they don't just look at over the past year what has happened. They look at over the past 20, 30, 40, 50 years what has happened, okay, and how to slow down the change of the climate, all right? They take into consideration the weather averages and those weather extremes. So those weather extremes would be like if right now, or last year, 2 years ago, during February break, where all of a sudden it was 80 degrees for no reason, right, where everybody went to the zoo, okay? That's an extreme in the middle of the winter, all right? So they take those into consideration, all right? Now, when we talk about climate, we're not just going to be talking about temperature, but you also have to talk about the amount of moisture. It's the same type of thing as when we talked about air masses, right? With air masses, it was always hot or cold, wet or dry, okay? Same thing with climate. When we look at the different types of climate, we're going to look at them as both hot or cold and wet or dry. They come together, okay, to make climate, okay? So when you are looking at climate, you first have to look at, let's start with the temperature, right? Temperature is going to be measured in two different ways. The first way is going to be the yearly average. So every year they add up. So December 31st rolls around, right? They look at the past year's monthly averages, add them up, divide by 12, and you get your yearly average for that year, okay? Well, they do that every single year to see, is there a pattern? Are we increasing in temperature? Are we decreasing in temperature? Is there a random year where we're hotter than the others? Why was it hotter than the others? Why was it colder than the others? Okay? The average for New York is 60 degrees Fahrenheit. Okay? We are approximately 60 degrees Fahrenheit. Okay? The second way is the annual temperature range. Right? Best way to put it is if you have the annual scale or the semi-annual scale, right? That's going to tell you how many times a year that they take the temperature during that time. Okay? Then we'll talk about, in general, looking at this, right? We have these monthly temperatures in both degrees Fahrenheit and degrees Celsius. Kind of like what you're doing with your project, right? But in this case, they're giving you both in degrees Celsius and Fahrenheit. You only have to give me one. Here's the high temperature, and the high yearly average is about 80 degrees Fahrenheit. And this is the low temperature, and it's about 63 degrees Fahrenheit. You know that is not going to be New York, right? Because our average low goes way below 51 degrees in January. Okay? And our average high is hotter than 88 degrees in July and August. Right? We know we usually hit the 90s, sometimes the 100s. Okay, so this is obviously not New York. Okay? Here's the graph that I'm expecting to kind of see with your project anyway, right? Except on the bottom, it's not going to be each individual month. It's going to be the 6 different checks, right? Something to point out, the low and the high follow the same pattern, right? But just at lower temperatures or higher temperatures, depending on which one you're comparing it to, okay? All right, so let's talk about the moisture, right? In order to talk about moisture, you have to talk about the annual precipitation versus the annual evapotranspiration. Evapotranspiration was one of your vocab words, right? It's when you take evaporation and transpiration and put them together. They combine them together. So how much water is evaporated or transpired, okay, versus how much water comes out of the clouds or out of the air. Okay, so if you have more precipitation, it usually means that you have more evapotranspiration, because in order for the water to get into the clouds to then come down as precipitation, you need more water to form the clouds before you can do that. Okay, so here we have precipitation versus evapotranspiration, right? So again, precipitation means the water comes down from the sky, right, and reaches us, versus how much water was actually brought up into the sky. Okay? Now, there are 4 different types of climates when we're talking about the moisture. Okay? There is, and you're going to want to leave a little bit of space in between each of them, because I'm going to talk about them, and you're going to want to jot down notes, because there's only 4 bullet points on here, and they're just the names, so just leave a little bit of a, maybe like a space underneath. Okay, so there's arid, semi-arid, temperate or semi-humid, which is us in New York. We're in about the temperate, semi-humid section, okay, and then humid. Those are the 4 types of when you're describing climate in terms of moisture. Okay, so it's how much moisture is there. So let's look at the first picture. The first picture, you'll notice, are very brown tones, right? There's no water there. There's very, very, very little greenery. So arid is more like a desert. Make sure if you're writing the word desert, you write desert and not dessert. Okay? One has 1 S, the other has 2. All right? You'll notice that there's not a lot of green. The stuff that is there looks dry, right? It's the types of plants that grow that do not need a lot of water. So things like cacti and whatever those fuzzy plants are that I'm highly allergic to, which is so much fun, by the way. We had one of those in my backyard, and it just like, as you were removing it, more fluff came flying at you. It was bad. Really bad. Okay? Versus semi-arid. If you look at semi-arid in comparison to arid, you'll notice that there is more greenery, quote unquote. It's still a tan color, okay, except for the bushes that are in the back, but they're not as desert-like. And yes, before you ask, Antarctica is technically an arid climate, okay? It's technically a cold desert. Desert just tells me that it's dry, okay? Don't just assume that we're talking about the fact that there's sand, okay? It just doesn't have a lot of precipitation that happens. Here's us in the semi-humid. Again, comparing it to the other 2 pictures, it's way greener. We have more plants. We have moss on the ground. There's more trees. There's more greenery, which then in turn will create more moisture in the air because there's more things to actually evapotranspire. Okay? And then this one is the humid landscape. If you can't tell what that is basically a rainforest, right? Notice the difference. As you go down in the amount of moisture in the air, as the amount of moisture increases, the richer the greenery looks, right? When it was just this picture, everybody looked at it and go, oh, that's really green, right? It looks really nice. But then you throw this one up there, right? And all of a sudden you're like, wow, that's a rich green. That means that there's more moisture in the air. Why? Because there's more things to grow with the water, which means that there's more things to evapotranspire. Okay? It's the water cycle all over again. If you don't have water, you won't have trees and plants, and therefore you won't have moisture in the air. Right? Does that make sense? Guys at home, does that make sense?
Yes.
Yes.
Perfect. All right, so there are some factors that are going to affect climate. Specifically, there are 6 factors that are going to affect climate. Okay? These 6 factors you have already heard about. We've already dealt with them. The first one is the latitude. We're going to go into detail about each of them. I'm just going to list them now. The second one is that global wind, those prevailing winds, and those pressure belts that happen on Earth. The oceans are large bodies of water. You could also write down, is it coastal versus inland? Because that's what that means, right? If you're near a large body of water, what happens to your climate compared to if you live further away? Those ocean currents, right? On page 4 of your reference table. If you have a warm current that comes by you, is it the same if you have a cool current that comes by you? Mountains. Mountains, I'm not talking about elevation because the last one is elevation. Okay? Elevation and mountains are different. When we're talking about mountains, we're actually talking about the structure and what happens if you're on the base of the mountain closer to the water versus the base of the mountain away from the water on the other side. Okay? When we're talking about elevation, we're talking about sea level versus altitude that's higher. All right? In a second, I'm going to show you a video explanation, and then we're going to write down some notes. The video explanation is there because of the fact that this is a very visual thing to see, okay? Now, in order to figure out climate, you have to, okay, take into consideration all of these factors together. You can't just look at the latitude. You have to look at latitude in comparison with the ocean currents, the elevation, the global wind, the oceans in general, and the mountains. Okay? So it's all 6 of these together. Do I want to show you that now or at the end? No, I'm going to give you guys the notes first, and then we'll go over the explanation, okay? We'll watch it at the end, probably on Monday. All right? So the first thing is latitude. Right? This should make sense to you, right? If we are closer to the equator, right, our climate is going to be very hot and moist. Why? Because we're closer to the equator. You have more sunlight that happens between the Tropic of Cancer and the Tropic of Capricorn, right? Those 3 places, the Tropic of Cancer, the equator, the Tropic of Capricorn, right, are where you have the sun at your zenith at different times during the year, which means that you're going to get more insolation. If you get more insolation, your temperatures are going to be much hotter. Normally, during any other year, right, during February break, you probably would have taken a vacation, if you could, to a warmer climate. Why? Because of the fact that it's warmer. It's freezing in here right now, right? It's also going to be more moist, right? And you could actually look at everybody's most hated reference table for this, right? See where this wet band versus this dry band versus the wet band? Really, you only have to worry about the United States, but in case they ask you, right, the equator is going to be more wet. Why? Because at the equator, there's more water, right? Look at the locations, right? If we go back to the last map, where'd you go? Where'd you go? Not wrong way. Come on, come on. Right? Look at the amount of, or the lack thereof, right here, of continents or land, compared to as you go up north more and more, right? So you have, and it also curves, right? So even if the amount of land is the same, the amount of land compared to the amount of water is much less. So it's going to get drier depending on where you are. Like I said, that's where this comes in, okay? Next one is the prevailing winds, right? We're not looking at the outside, or this time we're looking at the outside because we're talking about the fronts. We're talking about the jet stream, right? Those prevailing winds, and depending on how they move, they're going to bring in the heat. They're going to bring in the cold. It depends. With those jet streams, you know there's a polar jet stream that comes down during the winter due to the lack of sunlight. It comes further south because of that. Okay? Right? So here we have the climate zones that we were just talking about. All right? There's polar, there's temperate, and there's tropical. Those are based on the amount of sunlight, okay, that they receive. So it's determined by the angle of the sun's rays. Okay? Now, how are they actually broken down? They're broken down by the latitude of those sections. Right? So you have polar zones at the North and South Pole, you have temperate in between, and then you have the tropical zone, which is going to run from the Tropic of Cancer to the Tropic of Capricorn. Okay? That's also why if you look, right, when we did latitude, right, I specifically pointed out the North Pole, the Arctic Circle, the Tropic of Cancer, the Equator, the Tropic of Capricorn, the Antarctic Circle, and the South Pole. Because look what's actually how it's broken down here. Right? The polar zone goes from the North Pole to the Arctic Circle. The temperate zone goes from the Arctic Circle to the Tropic of Cancer. Okay? That's why I pointed those out like that. Okay. Large bodies of water. We've done this already. It's the same thing with temperature. Right? Your climate overall is going to be more moderate if you live by a body of water, if you live on a coastline, versus more inland, your climate is going to be more extremes, right? That all comes back to water's specific heat capacity, right? Notice on this map, notice, right? The places, yes, I understand that Mexico and Florida are at a lower latitude than we are, but even so, we're still in like the yellow here. Right? All of the edges of the United States are in yellow. Looking even on the west coast here, right? They're more yellow when you just take into effect or take into consideration the fact that they have more water near them, right? Versus the middle of the United States. The middle of the United States, that's also where the tornado's alley is. Right? Because they have more extreme temperatures there and more extreme climates, right? Again, it's going to be based on the fact that we are, this is the same picture, by the way, when we did inland versus coastline a couple of weeks ago, right? I said, look at where, we are versus if you go left at the same latitude, the temperature differences, how it will be extreme changes, right? Ocean currents, right? Those ocean currents are going to regulate extremes. So because water has a higher specific heat, it's going to give off and absorb heat at a slower pace, right? Because it needs more energy to do so. Well, when you're looking at page 4 of the reference table, right? If you have a warm ocean current that comes by you, right, it's going to heat up that water faster than if you have a cold ocean current, which means if you have a warm ocean current, you should have more precipitation than if you live by a cold ocean current, right? Well, how does that work? Well, and then after this, I'm going to stop, okay? Warm water currents and climate, right? If you have that warm water current, it's going to create warmer climates in those coastal areas, right? If that warm Gulf Stream comes up by us, it brings more heat with them, right? If it brings more heat, that means it's going to warm up that water, which is going to make more evaporate, creating more clouds, which creates more precipitation, right? If you were to look at one location versus the other, one would be rain, the other would be snow. Whereas cold water currents, right, like around the Pacific on the western side of the United States, keep the climates much cooler than the inner climate year-round for the fact that it has a cool water current. Okay? So that's where I'm going to stop today. We will start with elevation on Monday. Okay?